Monk. In this tutorial, we're going to talk about how to differentiate trig functions. And we're going to start with the most basic one, which I guess is going to be sine. Sine is probably the one that people get hit with the first time they come across this. So let's start off with the most simplest equation. Let's just say y equals sine x. So y equals sine x, and we want to differentiate that. So what we're going to do is, I'm just going to tell you the answer, okay? The answer is just y dash equals cosine x. And then I'm going to show you why that is. Now, I'm not going to show you the algebraic proof because that's going to take a while, and most of you probably won't be tested on that. But if you draw a curve, if you draw a sine curve on your graphics calculator, so I'm just going to turn it on and I'm going to clear everything, and I'm just going to draw a sine x curve. So y equals sine x. And then if you just graph that, okay, if it looks weird like that, just go into window and change things. So for x min, x max, just put -6 to 6. And then y min, y max, actually just put -10 to 10. And then y min, y max, just put -2 to 2. Right? And if you graph that, you get a nice sine curve. So let's talk a little bit about differentiating. So when you differentiate, you basically want the gradient of the curve. So let's say I want to find out what is the gradient when x is equal to 2.5, just a random number. So now if you go to second calc and you go to number 6, which is the derivative or the gradient, and then you go to x is 2.5, press enter, and it tells you the gradient is -0.8. Okay, it actually tells you when x is equal to 2.5, the gradient y dash is equal to -0.80114. Okay, now let's try it with our cosine equation. If you type in cosine bracket 2.5, what do you get? Okay, if you just type in on the calculator cosine 2.5, you get -0.8011. So this is actually true no matter which x value you choose, and that is why the derivative of sine x is equal to cosine x, which is really cool. Okay, so the next thing I want to do is show you guys how to differentiate some harder equations. So instead of sine x, let's now put a number inside of the sine equation. So let's do y equals sine bracket 3x. Okay, so what you do to differentiate that is, I hope you guys remember the chain rule. Now the chain rule says that you basically differentiate the outside of a function multiplied by the inside of a function. So what you do is you basically differentiate the sine part, so you write cosine, you're going to copy down what's in the bracket, and then you're going to differentiate the inside of the bracket, so 3x differentiates into 3 and you multiply them. So that's the answer. So you can simplify that a little bit, 3 cosine 3x. Okay, just in case you didn't understand what I was talking about, if I give you another one, y equals sine 4x, what you do is you differentiate the outside, so you're going to get cosine 4x, and then you differentiate the inside, so 4x differentiates into 4, and you multiply it by that, the derivative of the inside. So what do you get? You get 4 cos 4x. So just to show you that it's right, if I graph this equation, okay, if I graph this equation, I go y equals, clear the graph that was there, and I just type in sine 3x. Okay, just put in sine 3x and press enter. Okay, graph it. Okay, you get something like that. And now let's go to a random x value. So let x equal 0.5. Okay, what's y dash? Or dy over dx, same meaning. So let's go to second calc, number 6 for dy over dx. Put 0.5 in, and the answer is 0.2122. Okay, now let's do the same thing with this equation. So y dash equals 3 times cos 3 times 0.5, and let's see what the answer is. 3 times cos bracket 3, oops, let's just quit that first. 3 times 3 cos bracket, oops, why am I doing 3 times 3? 3 times cos bracket 3 times 0.5. And the answer is 0.2122, so it's the same. So we're right, this is the answer. Okay, this is the derivative of this function. Differentiates into this function. So you might say, well, how did I choose 0.5? That's actually the part that I just made up for checking. Okay, this is not part of the working out that you have to do. If the question just says differentiate it, then you got the answer by just writing that out. Okay, so let's show you guys another one. Oops, that's something from before. So let's come up with a few harder questions for you guys. So let's say I now do y equals, let's put a number in front. Let's do 5 sine bracket, instead of just 4x, let's do 5x minus 3. 5x minus 3. So yeah, what you're going to do is you're going to differentiate it by going dy over dx equals, and then you're just going to do, you're going to copy down the constant at the front. Now you can do that because it's a constant. Okay, it's a coefficient of the function. So you just copy that down, and then you change the sign into cosine, change the 5x minus, copy down the 5x minus 3, and then you're going to multiply by the derivative of the inside, which is 5. Okay, so you turn that into 25 cos 5x minus 3. Okay, let's do a check. So this is just a check. You select a random x coordinate. Let's just make x equal to 0.4. Okay, so I'm going to graph this equation. So let's go graph, clear it. Let's go 5 times sine 5x minus 3. Okay, so that's your graph. Oops. Let's change the viewing window a bit. Change the viewing window. Because the amplitude is now 5, I might have to change the y min, y max to -6 to 6 just to get that in there. And then I'm only interested in x is 0.4, so let's make x min -1 and x max 1. Okay, so you got a curve like this, and then oh, hello Randy, how are you going? So now what I'm gonna do is I'm going to test that out. So if I go second calc and then I go to dy over dx, and then I put in x is 0.4, I put it in there, and then I've got the gradient 13.507. So let's just write that down. Okay, now let's do a check. So let's go. This is still the checking part. 25 times cosine 5 times 0.4 minus 3, just to make sure that our gradient function is correct. So let's go 25 times cosine bracket 5 times 0.4 minus 3, and we've got it correct. So this is the checking. So checking is optional, right? This is the optional bit. You don't need to write this. This is what's the correct answer. Okay, so let's what should we do now? Let's do an even harder equation. Okay, let's put in something crazy. Let's put in y equals sine squared x. Y equals sine squared x. Where's all this random stuff coming from? Let me just delete all that. Okay, so how do we differentiate that one? Any ideas? Show how to work out. Shade the area between two curves. Okay. Area between three curves. Oh, okay. Randy, I will do that straight after this one. And Caleb, I will do that. Actually, I might do. So, Caleb, there's actually, you can't actually use the calculator to. Oh, you just want to shade it, or you actually want the answer? Because shading and doing the answer is not really the same. Anyway, so yeah, I might do that soon. So we will get to it. Okay, so now let's do y equals sine squared x. So y dash equals. Okay, so sine squared x, what you want to do is you want to rewrite that. So then you have sine. Instead of sine squared x, you rewrite it as sine x squared. Okay, so then y dash, what you're going to do is you're going to bring 2 to the front, and then you're going to go sine x to the power of 1, and then you want to differentiate what's on the inside. So what's on the inside is just cosine x. So you multiply by cosine x. So yeah, the important thing here is to realize that Okay, well, we might do that soon. Okay, so then we have. Well, there's actually people here, which I'm surprised about. So then what I'm going to do is do a little check again, but let me just write that down. So let's do a little check. When x equals 0.5, okay, so let's go y equals, let's put in our equation, which is sine x to the power of 2. Now, you must put everything inside bracket. Oops. Sine x to the power of 2. Actually, you might close the bracket first and then write to the power of 2. To the power of 2. Okay, so that's sine x to the power of 2. And then if I go to when x is 0.5, so I go second calc x is 0.5, what is the gradient? The gradient is 0.84. And now let's type this in to do the check. 2 times cosine 0.5 sine 0.5. And then you're going to type that in 2 times cosine 0.5 times sine 0.5. And then it's got, oops, sorry, I typed it in the wrong place. 2 times cosine 0.5 times sine 0.5. And that is 0.84. Again, so that's correct. So this is the correct answer if you want to differentiate sine squared x. Okay, so similarly, I can give you sine x to the power of anything. Okay, I could give you y equals, oh, there's all this other stuff again. I could give you sine x to the power of sine to the power of 5x. Okay, so before you differentiate, just change it to sine x to the power of 5, because these two mean the same thing. And then when you differentiate the outside first, so it's 5, whatever's in the brackets, to the power of 4, times by the derivative of the inside, which gives you cosine x. So it's 5 cosine x sine x to the power of 4. Now, you can also write just sine to the power of 4x. Same thing. Okay, so that's how you differentiate sine. I could talk about cosine, but I'm a little bit interrupted by some people who want to know other stuff, so I might come back to cosine later. So let's do area, shade the area between two curves. Let's do that first. Shading the area between two curves. I probably need a bit of a reminder on how to do it myself. Might just Google that. Okay, I think I might have something. Shading the area between two curves. So if I want to draw two curves, right? If I already have a curve. That's not a great curve to demonstrate. If I just draw sine x, oh, what happened in my window? Let's go negative 10 to 10 again, negative 3 to 3. Okay, and let's draw another line. So let's just draw y equals 0.5. Okay, so let's say I want to shade some of the area. Then I'm going to go to second quit, second draw. Where is the draw button? According to the user manual, there is a draw button. Here, see it. Second draw, and then I'm going to go to shade. Shade. Then I'm going to go to variable, and then go to y variable, go to function, and then I'm going to go to y2, and then I'm going to press comma. Where's comma? And then I'm going to go to variable, y variable, function, y1. This is probably not going to work, because why does this say second draw shade is number 7? Yeah, it should say shade. Okay, and then I'm gonna go to press comma again, and then I'm gonna go to second answer. What's that for? No, I won't do that. I'm just gonna put in two numbers. I'm just gonna put in 0, 2. Okay, and just see what happens. Press enter again, and then it should start shading. It's shaded the area between the two lines from 0 to 2. But why is it shading this? It's probably not that important to shade it, because shading it doesn't really give you the answer. It's so if I go to calc, might want to zoom in a bit. Window, let's zoom in. X min to 0, X max to 3. Just go -2 to 2. Just see what it looks like. And then let's just see what the intersection is first. Second calc intersects this point, guess this point here. Okay, and then let's say I want to, so x is 0.523. Let's just write that down. 0.523. And then let's write down the other intersection. Second calc intersects boom, boom, guess 2.61. Okay, so then what you would do is you would what would you do? Go back to the original screen and just go to shade. Where is it? Second draw, shade, y2, comma, y1, comma, and then let's do, what is it? 0.5235 9878, comma 2.6179. Finish the bracket. Does it shade? Yes, it shades exactly that area. Okay, but shading it does not really, Abby Hunter, find the area between, okay. So yeah, what I'm gonna do first is show you how to find that area. So then you just go to mode, wait, so you go to quit. Well, actually you can just go to, actually you do have to quit, and then you go to, what is it, math, and then you go down to number 9, which is integrate, and then you go to between 0.5 to 359878 to 2.6179, and then you just type in the equation. So what was our equation? y2 minus y1, y2 minus y1, and then with respect to x, and then you just press enter. It tells you the area. Now it might give you a negative answer, but you just need to get rid of the negative, so it's 0.6848. Now just to make sure it's right, because I don't want to leave it up to chance, so what were our two equations? We got y1, y is sine x, y is 0.5. So to find the area between 0.6848 is 2.6179, and then you go to one equation minus the other. So which line was on top? Oh, the sine curve was on top. So let's go sine x minus 0.5. Okay, so let's integrate it, which we're going to get sine differentiates into cos, cos differentiates into negative sine. So we're going to get negative cosine x minus 0.5x. Okay, if we integrate it. right? Because negative cosine x is going to differentiate into sine x. Negative cosine x is going to differentiate into sine x, is it? Someone tell me if that's right. Y equals negative cos x, y dash. Cos differentiates a negative sine, but there's already a negative, so negative sine is sine. Yep. Okay, so put in 2.6179 and then put in 0.6848. Let's take it away. So negative cos 2.6179 minus 0.5 times 2.6179 in brackets minus negative cos 0.6848 minus 0.5 times 0.6848. Okay, so let's type all that in. Randy, if you want me to find the area between three curves, you're going to give me the equation of the three curves, because I can't think of three curves to find the area between. Okay, so now if I put all that in, then I'm going to go negative cos 2.6179 minus 0.5 times 2.6179, and then I'm going to put that all in, and then I will get negative 0.44297 minus, and then I'm going to go negative cos 0.6848 in bracket minus 0.5 times 0.6848, and then I'm going to get minus 1.1169, and then if I put all that into the calculator, negative 0.44297 minus negative 1.1169, then I'll get 0.673. Was that the area? It was pretty close. It was pretty close. So I'm guessing the error was from my rounding. Alright, because I had to round. But it's... where is it? 0.6848, 0.67. It's so close. 6848, 2.6179. Are these the numbers I used? No. No, I'm using the wrong number. Why did I use 0.6848? I should have used 0.5235. Is there anyone actually watching this? No one pointed out the mistake. I substituted in the wrong number. Okay, I should have substituted in 0.5235. So this should be 0.5235, 0.5235, 0.5235, 0.5235. So let's do all that again. So it's negative cos let's just see if I can get that up again. So it's, instead of 6848, it's 5235. And then 0.5235. Okay, so the answer is negative 1.12. Okay, so if I put all that in, negative 0.44297 minus the answer, then I will get 0.6848, which matches what we had. Okay, it matches our graphics calculator answer. Okay, so the next thing I'm gonna do is Abby's question. So we got, find the area between curves y equals 2x to the power of 2 minus 8, y equals x squared minus 2x plus 6, and the lines x equals 4 and x equals 2. How do you do that one? What's hard about that? Sorry, Abby. So then what you do is you go 2x squared minus 8, put that in, and then you go x squared minus 2x plus 6. Okay, you graph it. X is negative 4 and x equals 2. Sorry, negative 4 and 2. So you can't see anything, so let's make it bigger. So y equals, window, let's just go negative 10 to 10. Let's go to the default one. We want to be able to see the two curves. Okay, so I can see the two curves. 2x squared minus 8. X squared minus 2x plus 6. Okay. It's sort of not very obvious. Not very obvious. Let's just zoom right out. So x is 2 and x is negative 4. So let's just go x is 2 and x is negative 4. Oh, sorry, you can't do that on this. You can't do that on this. So let's just delete that. Let's just draw a x is negative 4. Let's go y equals, make the window, make the y max a bit bigger, 20, and we don't need it that far down, it seems like. So actually we might. Let's just graph it again. Okay, so that's a bit better. So we want to go to x is negative 4. Where is x is negative 4? y is 24, so I can't even see it right now. Let's go to y is 30. And x is y min is negative 5. Okay, so let's go to trace. X is negative 4. So yeah, that's over there. Y is 24. What about the other line? The other line, when x is negative 4, y is 30. Let's just make y 35 then. Sorry, Abby, I take that back. You have a interesting question. Okay, so what we're going to do is we realize that when x is 2, so sorry, when x is negative 4, on one of the equations is y equals 24, and on the other equation it's 30, so they're not touching. So the two lines don't touch. Okay, they touch somewhere further than that. So at x is negative 4 to x is positive 2, alright, do they touch at positive 2? Trace x is equal to 2, y is equal to 0 there, and then when x is equal to 2, so they don't touch. So what you can do is you can simply just go integrate the line at the top, x squared minus 2x plus 6, minus the line at the bottom, and then integrate it between these two areas. Integrate between these two areas. So, sorry, these two boundaries. So then before we even integrate, I'm going to simplify it first. So then you got x squared minus 2x squared. Let's just get rid of the brackets first. So you got x squared minus 2x squared, so that's minus 3x squared. Oh wait, minus 1x squared. And then, so that's gone. And then you got minus 2x. And then you got plus 16. So then you're gonna go to integrate negative x cubed over 3 minus 2x squared over 2 plus 16x, and then substitute 2 in, minus substitute negative 4 in. So then you're going to go negative negative 2 cubed over 3 minus 2 times x squared. Oops. 2 divided by 2 is just 1. Minus 2 squared plus 16 times 2. Take away. And then you put negative 4 in there. Minus negative 4 cubed over 3 minus negative 4 squared plus 16 times negative 4. Okay, put all this into the calculator. Oh, that's one big line. One very big thing. Thanks, Abby, for your awesome question. So you go, I get tired just thinking about typing it in. 2 cubed divided by 3 minus 2 squared is just 4 plus 16 times 2 is 32 minus, and then you need all this in bracket. Actually, I'm just going to do it one thing at a time. So that top bit is 25.3. And then I'm going to do the next bit. So then I'm going to do negative 4 cubed negative 64. So that's negative of negative 64 is just 64 divided by 3 minus 4. Negative 4 times negative 4 is just 16 plus 16 times negative 4. So inside the bracket it's minus 58. So the answer should be 25.333 minus negative 58.666. And the answer is 83.99. Now double check with the graphics calculator as well. So I have y2 minus y1. Alright, so let's go Math 9 negative 4 to 2. Oops, did I do something wrong here? No. And then I go y2 minus y1. y2 minus y1. And then I go dx. Okay, let's see what that equals. Pray to God it's correct. 72. Oh. X squared minus 2x plus 6. Did I type that in right? X squared minus... No, because I put 16 over here. Another arithmetic mistake. Okay, this should be 6, not 16. So that's 6. So that's 6. People need to start pointing things out. Actually, I can only blame... Oh, no, wait. It's not 6 either. It's 6 plus 8, which is 14, not 16. 14. So that's 14x. Any other mistakes? So that's 14 over here. And that's 14 over here. Okay, so let's do all that again. Entry, so oops. Negative 2 to the power of 3 over 3 minus 4 plus 28. 14 times 2 is 28. So this bit should be 21.33. And then the next bit was negative 4. 64 over 3 minus 16 times minus 16 plus 14 times negative 4. Okay, so this bit should be negative 50. And then the answer should be 21.333 minus the answer. So then the answer is 71.99, which is 72. Okay. Ugh. 7 students. The most I've had in 3 days. Okay, so does anyone have any more questions before I go back to my normal tutorial? I might get a drink. Okay, well then let's go back to differentiating cosine. Let me just save this work. Can you derive and integrate a few exponential functions? Okay then. Randy, that one I can do. So let's start off with y equals e to the power of x. Okay, y equals e to the power of x. So if you draw a graph of that, y equals e to the power of x, and you draw a graph. Let's say you go to a point, so let's say we got x equals 0.3, just a random point. And you find out what y dash is. Okay, So y dash would be, so second calc, go to gradient, go to x is 0.3, and you can see when x is 0.3, y is 1.34, y dash is 1.34, the gradient is 1.34. Now the funny thing is, if you just go to trace and you find out what the y value is when x is 0.3, it's also 1.34. Wait, was it 1.3498? Let me just check that. Y, second calc, dy over dx, 0.3. Yes, it was 1.3498. So exactly the same. So when you differentiate an exponential function, you get y equals y equals e to the x again. So that's why when you differentiate it, you just get e to the x. Okay, now unfortunately it's not going to be that easy in the exam. So instead of e to the x, we might, for example, give you y equals e to the power of 5x minus 4. So then you've got to use the chain rule when you differentiate. Differentiate the outside, multiply by differentiating the inside. So you're going to go y equals e to the power of 5x minus 4, because that's differentiating the outside. And then you're going to multiply by differentiating the inside, which is 5, because 5x minus 4, if you differentiate that, you'll just get 5. So multiply by 5. So the answer is 5 times e to the power of 5x minus 4. Okay, let's check if we are right for that one. So if you graph it, e to the power of 5x minus 4. Oops. And then you graph it. Oh, and then let's say you go to a random point. Okay, the problem with this is the y min stuffed up. Let's just do -5 to 5. -3 to 3. Yeah, it's still like that. Anyway, e to the power of 5x minus 4. Let's just go to when x is equal to 1, what x is equal to 1.5. When x is equal to 1.5, this is just checking. Y is equal to y dash is equal to, sorry. So graph, then you go to second calc, number 6 for derivative, when x is equal to 1.5. Oh, the gradient is 165.57. What a huge number. Okay, now let's try typing that in. So let's go to, let's try typing that in. So check 5 times e to the power of 5 times 1.5 minus 4. Well, let's just go to, I might as well just type it in. 5 times e to the power of, what is that? E to the power of 5 times 1.5 minus 4. 165. So that's correct. Okay, this checking bit is optional. Okay, I'm just writing that to see that I'm doing it right. You don't need to do that. You just follow the chain rule. Okay, so now let's do a slightly harder one. So if I put in, let's say y equals e to the power of x squared minus 5x plus 7, okay, you can again differentiate it into, you copy it down again, so you differentiate the outside, which gives you the same thing, and then you differentiate the inside of the bracket, which gives you 2x minus 5. So that's the answer. That's the answer for differentiating. Okay, so any questions for differentiating before we move on to integrating? Anyone? Randy, should I move on to integrating? Okay, so integrating, well then let's, good to see you here, Tom. Let's integrate some stuff. So let's integrate e to the x. Now, the cool thing about it is because when y is equal to e to the x, y dash is equal to e to the x. So when you're going backwards, you're integrating. So it's just the same thing again, e to the power of x plus c, because when you have a constant, it differentiates into nothing. So you could have something here that we don't know about. So that's why we write it there. That's why we write it there. Okay, so let's give you guys one with a constant in front. Let's go 5e to the x dx. So what you need to realize is that pretty much anything we give you, you want to be able to get to it from the original equation. So from the original equation, if I multiply by a 5 on the left, what happens? I have to multiply by 5 on the right. So then the answer is just 5ex plus, now you would write 5c, but 5c is just a constant again. Anything times by a constant is just another constant that we don't know about. So you can just write c. So then, yeah, that's the answer. That's the answer. So should I give you another one for practice? Let's do integrate half ex dx. Okay, so what do you do then? Yeah, who is Randy? Who is Randy? That's a weird name. Anyway, so now half e to the x, how did we get to half? Well, we must have gone from the original equation. We must have multiplied by a half on both sides. Right? So then what do we get? We'll get, because when you multiply by a constant, you can put that inside the integral. So then it's just half e to the power of x plus half c, which is just half e to the x plus c. Okay, now let's make it slightly harder then. Okay, let's have something in the power. So let's do 5e to the 4x dx equals. Okay, so how do we do that? Well, again we want to start with the original expression. Okay, let's start with the original. We got e to the x dx equals e to the x plus c. Now, what happens if I multiply this by a 4 in here? Then I'm going to get a 4 here as well, but I'm also going to get a 4 at the front. Right? Because if you guys remember, when you differentiate, which is going from here to here, is differentiate, right? You have to differentiate the outside and the inside. So you differentiate the inside, multiply at the front, you're going to get a 4 at the front. Okay, so so then what happens is, instead of a 4, this is a 5. So what you're going to do is you're going to multiply both sides by 5 over 4. Right, and the reason for that is because then you can cross out the 4's and then multiply the 5 in, so it's 5e4x dx equals 5 over 4 e to the power of 4x plus c. So there's your answer. Vishal Shokay. Hello, Vishal. Okay, now if you don't believe me, you can try differentiating it. So let y equal 5 over 4 e to the power of 4x. If you differentiate it, right, you copy down 5 over 4 e to the 4x, and then you multiply by the derivative of the inside, which is a 4. So then the 4 at the front and the 4 at the bottom cancel each other out. So it's 5e4x, which is what we wanted. So this is the answer. Okay, now if you can't remember how to do that, there is a formula, but I suggest you still learn it by recognition, which is pretty much what I'm doing. But if you really need a formula, basically it works like this. Integral of e to the power of ax plus b is equal to 1 over a times e to the power of ax plus b plus c. Okay, so you can put a constant at the front as well, and then you can simply just replace the 1 with a constant. Okay, so using that formula, it might be a bit quicker for you, but you do have to memorize it, whereas using the way that I did before, you just need to know how to differentiate. So if I go, for example, 6e 5x plus 2, all you need to do is go 6 over 5 times e to the power of 5x plus 2 plus c. So then the answer is message retracted. Tom, what message did you retract? So there's your answer. Okay, now you can try differentiating it. If y equals 6 over 5 e to the power of 5x plus 2, when you differentiate, you copy the whole thing down, and then you multiply by the derivative of the inside, which is 5. So divided by 5 times by 5 cancel out, you get 6e 5x plus 2, which is what we wanted in the question. So this is correct. Okay, so now let's try and integrate something crazy. Let's try to integrate x cubed e to the power of 5x4, 5x to the power of 4 minus 7. Let's try and integrate that. If you can do it, you're a genius. Okay, let's get you guys to try that first, and I'll give you a few minutes and then I'll write up the answer. Okay, I'm guessing you guys have done that. So let's use it the recognition way. So integration by recognition. If y is equal to e to the power of 5x4 minus 7, then y dash equals differentiate the inside, which is 20x times e to the power of 5x to the power of 4 minus 7. So what is the difference? The difference is instead of 20, I just have 1. So what I'm going to do is I'm going to multiply both sides by 1 over 20. So if I multiply this left-hand side by 1 over 20, then I have to multiply the right-hand side by 1 over 20, so this just disappears. Okay, so what is the answer? The answer is 1 over 20 e to the power of 5x 4 minus 7 plus c. If you don't believe me, try and differentiate it. You'll get that answer. Okay, well, it seems like we have pretty much done it all. You guys didn't ask me any more questions about anything, so yeah. Nice work, guys. See you next time. Thanks for watching.